Greetings and thank you for tuning in to the Active Transportation Resource Center training series. The purpose of our flash trainings is to provide quick tutorials on key topics and tools for the Active Transportation Program applicants and prospective awardees. This training is part 3 of a 3-part series on the Transportation Injury Mapping System, or TIMS ATP tool. The Active Transportation Resource Center's mission is to assist California's communities, tribal areas, and schools with resources, technical assistance, and training to help implement active transportation projects. I will now turn it over to Ted Caltrans Senior Transportation Engineer and Active Transportation Program Manager.
Thank you, Jane. I am excited to have this opportunity to present on the TIMS ATP tool. This training is the 3rd of 3 flash trainings. In this training, we're going to be going into step-by-step examples for non-infrastructure projects. The objectives for this Part 3 flash training is to give a quick overview of what we talked about in Part 1, to provide live demonstration of the TIMS tool's 6-step process for non-infrastructure projects, and finally to provide more information on how to best answer the safety question in the Active Transportation Cycle 4 application form. So a really quick overview of Part 1. When I mean Part 1, it's the flash training that is posted separately. In that flash training, we did an overview of the TIMS tool, provided a little bit more information on why the tool was developed for the Active Transportation Program. We went into how to use the tool to capture the required maps and summaries. And in doing that, we showed screenshots of the 6 steps that the tool uses. And we talked a little bit about how to use the summaries that the tool produces to help address safety in your application, and we stress ways to maximize the value of the TIMS ATP tool. For this flash training, our focus is going to be on non-infrastructure projects. And in doing so, there was one project that was funded recently, and it happened to be funded in Humboldt County. It was to address the safety at 2 different school districts. So it gives a great opportunity to show kind of 2 different examples of using the tool within one project. And as we go through these examples, we'll talk about the instructions and then go through each of the steps. At this point, we're going to switch over from the slides to the actual TIMS tool. Okay, here we are on the TIMS website, and this website is located at the web address that you can see at the top left, tims.berkeley.edu /, and you'll see this home page, and you see that I'm signed in. If you don't have an account, you'll want to click essentially at this place on this page, which will allow you to create an account. And then once you create an account and you sign in yourself, you'll see your own account name right there. There's 2 ways to get to the Active Transportation tool. One is clicking on the tool. Another way to get there is to come down, and this is kind of a visual pictorial of the different tools that are available. And there's an Active Transportation one here. You can click there. It takes you to the same place as if you had clicked right up here and gone down to Active Transportation Maps and Summary Data. Okay. From here, the first thing I want to point out is if you're a first-time user, as noted right here in this note, that we recommend that you view and or print the step-by-step instructions that are available. You can click right here and get to these instructions, or you can click the Help menu right here, and a separate tab opens up, and then you can see all of these detailed instructions that let you know what's going on in the tool. All right, so I'm going to close that extra tab here, and now I'm back. So my project is in Humboldt County. So I click on Humboldt County, and like I said, there are 2 different schools that are being proposed for improvements. One of them is in the city of Fortuna, and the other one is in the community of McKinleyville. So I'll go ahead and start with the City of Fortuna. So this project is proposing to improve the schools. First thing I want to do, it's a non-infrastructure project, so I definitely want to be looking at all roads in the area. I want to be looking at both peds and bikes in the area and all crashes. I recommend that users extend the window of crash data to maximize the crash trends that might show up. So I've now just maximized my years from 2006 to 2017. I can see my total crashes that have occurred in all of the city of Fontana during that time is 41 bicycle and 41 pedestrian. And there are my city limits. So my school district just happens to match my city limits. So I don't want to, like, right now I'm set on a 3-mile by 3-mile box, and that box doesn't quite cover everything. If I click the 10-mile by 10-mile box, it'd be too large. But I do have the opportunity to look at the whole city county, and I can click on that, and now the boundary is bold. So with that, I've now clicked on that. So you can see that at a statewide level, the crash intensity on this first heat map, there's no red, because from a statewide perspective, the number of crashes in Fontana are below some of the highest locations across the state. But when I click on my community heat map, it changes the intensity to my specific community of concern. So now my project is the entire area. So when I do my crash boundary, I can simply quickly draw a boundary around this, because it's that easy to do my crash boundary. I've now incorporated all the crashes within, and the tool has already eliminated any crashes that have occurred outside of my boundary. And that shows me my diagram. So I do want to point out one thing, is that, so when I look at this crash boundary, it definitely is all that is required. But one thing an applicant can do to kind of give it a little more visual, because I think one you'll see right here, I want to try to depict where my actual schools are. And so I'm going to delete my boundary. I'm going to start over. And I want to I have a school that's right here. This is approximate. City of Fortuna is watching. They'll say, oh, that's not exactly where the schools are. But I think there were three schools in this area. And then, if I'm remembering correctly, there was one school that was right off of this. Sorry. There's a school here. And the last school was right here. There was a school there. Now I'm going to come back here. So that's my 3 school locations. But now I also want to capture all my crashes, so in addition to that, I can now do my one boundary around the whole limits to capture all my crashes from my summary. But, so if this is what you proposed and you show in your application, what you're showing to any evaluators that might be looking at your application are my schools just happen to be located in some of the highest crash concentrations of my community. So it really kind of emphasizes the need for a safe routes to school non-infrastructure application, or it really supports that. Now I can go down here and look at my crash map. It doesn't double count, so going back up, I have areas within areas, but it doesn't double count those. It just looks at the maximum area. And here you can see all of the crashes that are occurring within my boundary. You can kind of see the limits of where the school. You get an opportunity to click on any of these. You can click on any of these symbols and you can see information about that particular crash. It's really neat. You can also click down here. It says click here for street view. If you click on the street view, it provides more information about that specific location. Right here at the top right, it shows you who was at fault. And in this particular case, the only 2 parties were 2 bicyclists. The 2 bicyclists hit each other, and the second bicyclist was at fault. The other thing it allows you to do is it allows you to see where you're at within the map, the lower left. But the really neat thing is you have this street view right here. And so you can see exactly what the dynamics of the situation were where that crash happened. So what we're seeing is there was sidewalks there. We don't have bike lanes. These are bicycles crashed. There's no bike lanes. Neat thing is you can double click here. It takes you inside a street view. So you go to a new thing, a new window pops up. And what I want to point out is this really neat tool. By clicking on the dates, you can, anytime Google went through there, you can see what the street looked like at that time. So you can see they went through it 2017, they went through it 2012, they went through it 2015. So you have the opportunity, if I want to look at 2015, I click there, and now I'm looking at what that street looked like in 2015. So as you evaluate your projects, you may find that very useful. So I'll get back out of there. I'm going to go back into the TIMS tool. So now I have my heat maps and my project area defined. I'm going to go in, I'm going to look at my results. So the first results are built into the TIMS tool, and this shows me bar charts over time of all the crash years. So at the very beginning I told you it was beneficial to expand out the number of years, and the reason that is beneficial is now when you get down to these bar charts, you get to see what's happening over time. And the top chart is for bicycle collisions, and you see that there was a drop in bicycle collisions back in 2011, but for Ped collisions, they've kind of gone up in recent years. They've gone up. So that might be something worthy of talking about in your application. The next summary that the tool provides is a list of all the crashes that occurred within your project limits. And something that's kind of neat, if you're looking down through here and you're looking at a crash that draws your attention, if you click on the left side, it brings you right back to that crash. It brings you back to your project-specific map, and now it shows you visually where that crash has occurred on your map, and it does give you that opportunity again to click on the street view. So to get back to where I was, I have to scroll back down. So I looked at the summaries that are built into the TIMS tool. Now you want to go into the summaries that are provided in the larger suite of TIM tools. So you click on this Open End-Up Collision Summary button. At this point, I'm going to walk through the summary tabs that are built into TIMS, and there's 4 tabs that might be interesting: Overall, a Victim Summary, a Ped Collision Summary, and a Map. Looking at the overall summary, the first one talks about just the severity of crashes. And what you see is this location or this area has a little more tendency to have lower severity crashes, but that's generally expected. You come down, and this is a neat chart because it gives you this first large column that are all the Ped crashes lumped into one, but the bicycle crashes are shown what types of bicycle crashes happen. So you have a lot of broadsides, which is pretty typical, but you have a lot of rear-end crashes. You have a lot of hit object crashes. So the bicycle actually hit an object in the street. Maybe they hit a parked car. Maybe they hit a signpost. But that's worthy of looking into. But there's good information there. The next thing is this chart here talks about when the crashes occurred in time of day and days of week. And you see generally crashes occurred in all times of the day and all days of the week, but you see this concentration of right after school. So if school gets out at 2:50, say, you have a lot of crashes right at 2:50 all the way through the evening commute. So that kind of gives you a time of day to think about what users are out there at that time of day, and you want to really be addressing or focusing your education campaign or enforcement campaign to issues around that time of day. This next chart talks about the primary collision factor that occurred right at the time of the crash. And some of the things you'll see here is you see unsafe speed. So right there, an education campaign for drivers, maybe by the schools, or that speeding is an issue, or maybe it's an enforcement issue. It kind of justifies that. You have bicyclists riding on the wrong side of the road. 20% of the crashes, so the bikes are on the wrong side of the road. Clearly a need for tailoring your education campaign to bikes and how they ride. You have pedestrian right-of-way was violated, meaning that car probably hit a pedestrian in a crosswalk. You also have pedestrian violations where the PEDs were at fault 8% of the time. So it's good information to go through. Now looking at victim summary and things, the first chart is the same. The second chart shows you a quick breakdown. You had one driver, so one driver out of all these got injured, but mostly you have a nice even split between PED and bike. Safety equipment is generally, it may show when bicyclists are not using a helmet, but it's a relatively small percentage. What it generally shows is that, it's not an issue. But this last one is a really important chart, and that is the age of the victims. If you look right here in this area, it's an extremely high percentage of the victims are 14 and younger, which corresponds to that first heat map where we were showing where the schools were in connection to the hot spots in the community. Is the crashes are occurring around schools, and they're the younger kids. So really very data-driven way of demonstrating the true need for this project. And there's one last, is Ped Collision Summary. This filters out the bicyclists, so this is just looking at the PEDs, but it provides some nice information. Drivers must yield to pedestrian in the crosswalk, so over a third of the time the drivers are hitting pedestrians in crosswalk. Unsafe speed, so the drivers, that's a big issue. And you have the pedestrians need to yield. This is kind of a visual bar chart of the information above. So again, the vast majority are PEDs that are in crosswalks getting hit by cars. So you hope to address that in your education and your safety campaigns. This chart here shows that most of the crashes are all happening during the daylight, so it's not a lighting issue. It's most likely an infrastructure and education issue. And finally, most of the crashes are happening when it's either clear or cloudy, so showing it's not a weather issue. Okay, that's the end of that example, and that was for the city of Fortuna. But this ATP application has two different cities, two different jurisdictions. It's one non-infrastructure. So now what an applicant would do is go down here and hit this print button and then print all the information related to this Fortuna school, and they're going to have to store that separately. When you're in the in-depth collision summaries, you have to go to Google or you have to print within there. One thing you're going to find using the in-depth collision summaries is we're using Internet Explorer, and as you could tell, they just showed up clear and formatted correctly. But when you print out of Internet Explorer, oftentimes people's computers, the formatting on those prints will get distorted. So a user, what UC Berkeley and Caltrans recommend is, if possible, you want to use Google Chrome when using the TIMS tool, because if you find that your prints are distorted and then you try doing the same print using Google Chrome, they usually end up being formatted correctly. So at this point, the user would print out all of their information for the Fortuna project. And then they're going to come over and they're going to change it. Still Humboldt County, but now the city of McKinleyville is not an incorporated city, so it's in part of the unincorporated area. So by changing my city, I'm going to lose my past data, and it's warning me. And I say, yes, I want to continue. And I still have my wide range of years, so I'm good there. I still have everything checked. I'm good there. Now I've got to find my project in this large county of Humboldt. And I know my project, McKinleyville, is up above the bay. So I know it's in this area, but I don't know exactly where it's at. I can click here. If I click there, I see my 3-mile by 3-mile window. I can go down and look at my community map, and I can see part of McKinleyville. So one, I can tell that a 3-mile by 3-mile map wasn't enough. So I'm going to go back up. If I click my whole city/county jurisdiction, that's going to be the entire county, and I don't want that. So my next option is going to be a 10-mile by 10-mile map. And let's try that right there. If I come down here, this school district is essentially, it's bordered by this river here. It's bordered by this road right there, and it comes across up here right at the mouth of that creek right there. So essentially the window I selected was correct. It could be a little over, but I think that'll work. So I will show my boundaries. Again, I'm approximating it. If you're the user or the actual applicant, you need to be more exact, but I'm taking this generally off what I saw in the application. Okay, so that shows me my boundary. Now, similar to the last one, the schools on this example are also in the middle of this hotspot. So this is another situation where an applicant would want to zoom in and provide the actual school locations. For this, let's just say the school was right there. It's not exactly where it was, but there's a couple different schools. Let's say they're right there. So I can zoom back out. And that right there, let's say that shows my one school, and it shows the overall boundary that draw to that school. Now I'm ready to move on. And there are the crashes that occurred. I'm going to keep moving on, and we can now see, again, the bicycle crashes are pretty standard. We're getting about 2 to 3 a year, and the pedestrian crashes are going up significantly in the recent years. And what, you could really make the case, if this area doesn't do anything, they don't have a non-infrastructure project, or if they don't have significant infrastructure improvements, they are likely going to expect, on average, maybe 5 pedestrian bicycle crashes per year. So by doing a non-infrastructure project, you can hope to significantly reduce that number. This is a list of all the crashes. You can also close these down for ease. So now we'll go into some of the specific summaries for McKinleyville. Okay, looking at the specific summaries that are in the TIMS suite of tools. I'm not going to go through all of them, but again, you see the overall severity. You can see the types of crashes that occurred. Again, broadside are the most for bikes, but several other types occurred. You see that most of the crashes are occurring after school, during the after-school commute, or right afterwards. It gives you a feel for the primary collision factor, some of the highest ones. Improper turning, you have unsafe speed is high. There's an equal split between pedestrian right-of-way, meaning the cars aren't yielding to pedestrians or pedestrians aren't yielding to cars. So there's good information there. Okay, now the next tab I want to look at is the victim summary tab. And then coming down through here, that same graph again, the breakdown of the Ped bikes again, talks about safety equipment. What I really want to focus on is down at the bottom, and what this graph here is showing us is that a very large percentage of the overall crashes in this community are actually occurring with people that are 14 and under, which are, kids, we don't know for sure that they're students, but there's a good chance that a lot of these are students walking to and from school. So shows a safe routes to school type program to be very important. And this would want to be stressed in the application. And coming up to the Ped Collision Summary. So for the Ped Collision Summary, again, you want to look at some of this first chart talking about the largest percentage of crashes are because drivers need to yield to pedestrians. And then there are some other issues with pedestrians outside the crosswalk. Then you also have unsafe speeding, unsafe speeds by drivers, and then several others. So you, as an applicant, you'd want to really understand each of these and be able to explain how a program would be addressing the top crash types. And then here's another way of summarizing that data. It's broken down into different categories. Clearly, the highest individual percentages of crashes are actually with the people in the crosswalks, but then there's a significant issue with people on the roads or not in a crosswalk. And a lot of that might just be because of lack of infrastructure, but a non-infrastructure program can help educate people on what side of the road they should be walking on, what they should be doing if there isn't any infrastructure for them, if there's not a marked crosswalk, or if there's not a bike lane or sidewalk to be utilizing, what they should be doing. So anyway, that's great detail. Something here that's worthy of pointing out is that there's a lot of crashes happening in the dark. Some of them no street lights, some of them dark with street lights. It's a high enough percentage that there might need to be some training or maybe consideration of what's causing that. And then very few crashes are happening due to weather issues. That probably isn't that important for NI projects, but it may be worth discussing that this isn't a weather issue. It kind of is not an infrastructure issue. It's just more non-infrastructure could be very useful in addressing crashes that can't be caused for other reasons, or can't be corrected for other reasons, I should say. Okay, that is the end of our analysis of the detailed summaries. So now we'll go back to our slides. Okay, now we're back in the slides. We're just gone through our live demo, so we have a few more slides to wrap up this class training. The next thing I want to talk about is answering the safety question actually in the application. In the ATP application for NI projects, they expect applicants to reference the heat map, the collision map, and collision summaries provided, and discuss why your agency chose this program area as a priority for addressing ongoing safety, and discuss how the program corresponds to the types and location of past collisions. It goes on to say, as appropriate, the discussion may include how the NI program elements educate, they encourage, and they enforce. Those are just examples. But what you should have seen in the past live demo that we just went through is there's a lot of good information in the maps and in the summaries provided by the TIMS tool that an applicant can leverage to make this exact case. You really should be able to show the priority for the location you're addressing, and then also show the types of collisions and how they directly correspond to the specific non-infrastructure program elements that you're going to be providing. So, for enforcement, you should be able to reference, if enforcement is a large element of your NI project, you should be able to show that speeding is an issue, that a lot of the crashes are occurring with people inside of crosswalks and stuff like that. And then to address where the crashes are happening outside of crosswalks and where pedestrians or bicyclists might be riding on the wrong side of the road or something like that, then that's where education may occur. So those are just how you pull it all together. And quickly, this was covered in part 1, but I want to cover it again. and that is the real value of the TIMS tool. I mean, obviously in the first bullet here, we think the TIMS tool is going to help the ATP program and help the evaluators really get a feel for which projects have the most significant safety issues. But beyond that, we would love to see local agencies and community groups be able to use the TIMS tool to really prioritize the limited safety funding and transportation funding that they have to projects that will make the biggest difference for active transportation. I want to remind everybody that this TIMS tool is a work in progress. We think it's a good tool right now, but both UC Berkeley and Caltrans would love to make continued improvements to this tool. So if, as you're going through the tool, if you have suggestions for additional tables that you envision would be helpful, or additional mapping features that would be helpful, we encourage you to send those suggestions to UC Berkeley at the email here. UC Berkeley will summarize those suggestions and provide them to Caltrans at the end of the Cycle 4 call for projects. But if you have a general active transportation guidelines or application question, please do not forward those to UC Berkeley. Instead, those need to go to Caltrans, your agency's district ATP coordinator. And there's a link there to provide you information how to contact them. So finally, I want to give a big thank you to everybody that's watching these videos and that is using the TIMS tool and hopefully leveraging that tool and just leveraging their transportation funding to improve the safety and mobility of non-motorized users.